Welcome to Young Asia Television.
Presented by the National Science Foundation of Sri Lanka.
Hi, and welcome to yet another Mihimadala, where we delve into the secrets of nature and follow the development of human civilization.
ගහකොළ මල් සුසැදී පනනල රැඳි සුරැකි ජීවිතයේ පිපිරෙන්නයි ගිනි කඳු ඇත්තේ කලායන්ට දිය මං ඇත්තේ මද සුළඟද රළු විය හැක්කේ කඩා වැටේ උල්කා අහසේ දැනුවත් විය යුත්තේ විද්‍යාවෙන් තේරුම්ගෙන ලෝකය ජීවත් විය යුත්තේ මේ මඩ.
The Industrial Revolution of the 1780s ignited and accelerated development across the world and in many different spheres of life. The Industrial Revolution, which began in the United Kingdom around 1780, was just the beginning of an age of technical innovation that continues down to today. Back then, revolutionary inventions included the steam engine and innovations in the textile industry and mechanical engineering. By 1840, the Industrial Revolution spread to other countries of Europe, including France and Germany. During this time, development of the steel industry and the railway infrastructure took place. This second stage of the Industrial Revolution came to an end in 1900. The third stage of the Industrial Revolution was from 1900 to 1950, and the United States was central in its development, which resulted in the advent of the electric motor, the chemical industry, automobiles, and various consumer goods. The fourth stage of the Industrial Revolution has spanned from 1950 down to today, and places like California and Japan are central in its development. As we all know, this stage saw the development of the chemical and electronics industries. That is development up to today. So what does the future hold? Let's take a look at what's coming up on today's show. The Industrial Revolution and Nanotechnology. Nanotechnology in historic inventions. The development of nanotechnology. Nanotechnology in everyday life. Different stages of the Industrial Revolution took place in various places across the globe. And now we take a look at the fifth stage of this revolution and the technology that resulted from it. There are indications that nanotechnology will emerge in the fifth stage of the Industrial Revolution. Nanotechnology is a technique based on nanoscale manipulation. With this nanotechnology, there can be a lot of high-tech products produced using minimal energy. This graphic that you now see shows you just how small one unit of the nanoscale is. Nanotechnology is all about assembling building blocks on a very small scale. Assembling anything on a scale of 1 to 100 nanometers can be considered as nanotechnology.
Now that's what we are trying to do. We are trying to produce devices that are of the order of or below the size of 100 nanometers. So once you start doing that, you increase the functionality, you increase the number of devices you can put, and you increase the speed in which you can start talking to components. So suddenly the whole design philosophy changes, and you are able to make extremely efficient devices, extremely powerful devices that can compete with the best currently available. So to take examples, you can start addressing faster computers, you can start addressing energy as a potential problem area which can be solved using nanotechnology to design things.
It is believed that the fifth stage of the Industrial Revolution will be driven mainly by developing countries like Brazil and China.
The word nano, which is derived from the Greek language, signifies something very small or dwarfish. Nanotechnology is something that is very much a part of nature itself. And one of the best examples of nanotechnology innovation that can be found in nature is the lotus leaf.
Consider what happens when a drop of water falls onto a lotus leaf. It slides off its smooth surface. The texture of the leaf cannot be detected by an ordinary microscope. The reason for this is that as a result of nanotechnology, the leaf has become hydrophobic.
Interestingly, the whole area has developed by using the effect called the Lotus Effect that you see in your lotus plant. So what we are trying to do is to better nature, and that's what it's all about. Nanotechnology is making devices and designing devices of the smaller scale in order to mimic nature. The only difference between nature and what we are doing is to try and make it much, much faster, which is the remit of electronics, because you can start producing devices that work in the gigahertz range, which is extremely fast.
We can trace the use of nanotechnology to the ancient Romans. When producing the 4th century Lycurgus cup, the Romans used 70 nanometer silver colloids to produce color and sparkle. It is also possible that the 5th century masterpieces at Sigiriya were painted using oil-based paint incorporated with metal nanoclusters.
With nanotechnology being so much a part of nature and being used in innovations of the past, who really identified it and applied it in the modern world?
It is Richard Feynman who is cited as the inspiration of modern technology. In a lecture titled "There's Plenty of Room at the Bottom," presented to the American Physical Society in 1959, Feynman outlined the challenges and opportunities faced by engineering, starting from the atomic scale.
In this, he not only accurately predicts that you can make devices of the smaller scale, but you can manipulate things in the molecular level. Now, if you can manipulate things in the molecular level, you can design systems. And he said it would be surprising that people would say, it's taken so long, that's 1959, for someone to even think about this. But he was extremely far-reaching person with much foresight, and that's why he probably got his Nobel Prize in the area he worked. So that's where nanotechnology really was probably first coined and came through.
It is the electronics industry that has, from a technological perspective, pushed for ever-increasing miniaturization. The invention of the transistor by John Bardeen, William Shockley, and Walter Brattain in 1947 was the beginning of the miniaturization revolution. Jack Kilby and Robert Noyce took it a step further in the late 1950s when they both independently conceived the concept of the integrated circuit, which allowed all the components of an electronic device to be fabricated on a single crystal of silicon. This led Gordon Moore, the founder of Intel, to predict a doubling of the number of transistors per IC every 18 months. Moore's law held for the last 40 years. Unfortunately, due to fundamental limits associated with quantum mechanical tunneling in semiconducting and electronic materials, it is envisaged that this miniaturization cannot continue beyond 2010. We then turn towards nanotechnology. In 400 BC, Democritus of Abdera asserted that all material things are composed of extremely small, irreducible particles called atoms. British scientist John Dalton brought forward a firm scientific theory of the atom. A buckyball is a compound made of 2 carbon-60 atoms and is shaped like half a football.
A carbon nanotube is composed of a single layer of graphite with open or closed ends.
In the future, efficient, high-power solar batteries can be developed with the aid of nanotubes and carbonic materials, presenting an excellent solution to the energy crisis.
Now, why do we want to do nanotechnology work? Well, in the case of nanotechnology, one of the key aspects that allow us to do these things is being able to do many functions at the same time. Now, for an example, if you were to make components closer and closer together, it means you can get electrons to move from one point to the other. So, in a transistor, to move electrons from the source to drain, the distance, if the distance is reduced, you can make it very much faster. And once you make it faster, it means that you can have more processing power. You can do things in parallel, you can do things with more efficiency. And in the case of reducing the dimensions in one direction means that you can put 4 times more components. So, in the case of semiconductor industry, very interestingly, when we talk about silicon as our platform technology, in silicon we talk about real estates. And what is real estates is the number of chips, and in our example of real estate is the number of buildings we can put. And when we are talking about buildings, the more buildings you put, the bigger the society, the bigger the city, and the more functions that city can perform, compared to say a village where you have small amount of components. Then in terms of talking to each other, in the case of sophisticated societies, you can use your phone, you can use your mobile phone, you can use your computer to send emails, you can use text messages. Similarly, the closer people are, the more easy it is to communicate and the faster it is to communicate. So therefore, by having smaller devices, you get higher speeds, you get more functionality, and certainly it allows you to be more efficient in terms of being able to do things.
If you're still finding it hard to understand nanotechnology and the nanoscale, let me give you another example. Consider the human hair. To the naked eye, it appears to have a minute diameter, but under nanoscale magnification, it appears to have a diameter of about 200 meters. The nanoscale is really that small. But now let's take a look at some everyday applications of nanotechnology. Imagine a medical device that could travel through the human body to seek out and destroy small clusters of cancer cells. In the future, with nanotechnology, through the use of nanobots that could enter the body, it will be possible to detect, diagnose, and deal with such illnesses. These robots will target and treat only the cancerous cells.
Well, in terms of society, nanotechnology is going to be all pervasive in, say, probably in the next 10 to 15 years. It will hit us, and when it hits us, we will not know what has happened. You can take many examples of it, and nothing is more important to us than the healthcare sector. So, for example, in the future, you might have just a plaster with a forest of nanotubes or nanotechnology on it that you either put on your forehead or on your chest. And this will allow you to monitor your EEG and your ECG. Now, in monitoring it, we don't need to power it. It can power itself remotely. We can put energy scavenging networks on the back of your plaster that effectively takes the electromagnetic radiation around you and powers your sensor. That sensor then can feed into your local area network wirelessly, and that signal can be monitored in a computer. When you monitor that signal in a computer, it will tell you when you are under critical conditions or dangerous conditions that can remotely call upon your doctor and make sure that your well-being is preserved. That's 24/11 healthcare. You can talk about diagnosis. We can have DNA assaying, which allows us to be able to monitor disease more carefully. We are able to diagnose things, identify things much more carefully. We can also talk about cures, and one of the key areas we are looking for in terms of curing is examining cancers and seeing how cancers prevail in the body. And in the case of cancers, we can very accurately deliver medicines to just the cancerous cell and activate it only on that. So accurate delivery of large quantities of medicines to kill cancer cells. We can also use temperature to kill cancer cells. In this case, we can move our agents of nanoparticles through the body to target particular enzymes that are given out of cancerous cells. Once the delivery payload is taken to the cancer cells, we can hit it with some infrared lasers and then activate the nanoparticles in order that it absorbs the heat to kill the cancerous cells.
With nanotechnology, it will be possible to design clothes that do not need to be washed. This is due to the fact that the cloth produced would be smoother and not collect as much dust and dirt as the clothes we wear today. Paint produced through the use of nanotechnology has a superior quality to normal paints. Nanotechnology can also be used for sanitation purposes in the household. The discovery of self-cleaning glass through nanotechnology has made the maintenance of skyscrapers a lot easier. The thirst for energy from fossil fuels has arisen due to global modernization. This burning of fossil fuels by humans is the largest source of emission of carbon dioxide, causing pollution and also contributing to global warming. As a solution to this problem, nanotechnology is being used to develop hydrogen fuel cells that would produce energy through the reaction of hydrogen and oxygen, releasing water into the environment as a byproduct.
Now, in the world situation, it's very interesting. There are very few products out there that is purely based on nanotechnology. When I say products, these are products that are marketable. Probably the main products that are out there are in the rubber industry. And in the case of polymers and rubbers, what is happening is you're putting nanoparticles such as carbon nanotubes into rubbers to increase its strength. So there are a few products, but the main emphasis, the main drive to nanotechnology is not yet here. So the key is, if we can get into the nanotechnology field now, it means that we'll be able to compete right at the beginning. And if you take an example, in the US, there's over $1 billion being spent. In Japan, it's about $700, $800 million on just nanotechnology programs. All of this is being done because we believe, industry believes, governments, institutes all believe that in the future, nanotechnology will make things cheaper, faster, lighter, and highly more efficient. And therefore, if you do not address it now, you will be putting your whole future at risk. So it is a very, very important now to get into nanotechnology and be able to contribute not only to the fields as in production, but energy and helping out in other areas that are benefit to society.
Space elevators that were famously predicted by science fiction writer Arthur C. Clarke will be a reality in the near future. The cables developed with nanotechnology are 20 times stronger than steel, half the weight of aluminium, and can withstand twice as much heat as diamonds, with virtually zero heat resistance. In the future, these cables will connect a space shuttle to an Earth-based spaced elevator center and will transport people back and forth. Although the Industrial Revolution has led to many innovations that have made our lives far more comfortable, it has also had some horrible side effects, like pollution. This occurred as a result of people's negligence and not due to a lapse in technology. As we've seen, some of the most valuable innovations have had a positive and a negative impact. So what about nanotechnology? As it develops in the future, is it likely to have a great positive as well as a negative impact? Scientists are paying great attention to the problems faced by people in developing nanotechnology. Among the problems faced by people, poisoning caused by nanoparticles is a major concern.
it's hard to predict what the exact fallout of nanotechnology will be. But what we are going to discuss next is how we can contribute towards developing nanotechnology here in Sri Lanka.
In the case of nanotechnology and whether Sri Lanka can make an impact, I believe now is the time for us to do something. In the world field, Sri Lankan scientists and technologists are effectively creating the news that is allowing nanotechnology to profit in the Western world, in other countries. So if we can bring some of these talented Sri Lankans back, it would be extremely useful. I believe at present our President Rajapaksa and our Science and Technology Minister Professor Tissa Vitarana are in the midst of discussions in setting up a nanotechnology institute. Now, should this nanotechnology institute take place, I believe it's our responsibility collectively as Sri Lankans to help make sure that we impact on the world scene with our Sri Lankan brilliance and innovation in order to make sure that Sri Lanka can really make its mark in the technology field. We can make world products that are going to be world beating and the most efficient products out there. And I sincerely believe that can happen, provided there is the will of the people to work together as strategic teams in order to do it.
Perhaps the development of nanotechnology in the future will lead to amazing things, science fiction brought to life. Well, that's about it for the show today, but thank you so much for joining us on Mihi Madala, brought to you in collaboration with the National Science Foundation. Till we meet again, you take good care of yourselves.